Well, greetings out there in YouTube land, and welcome to today's big video, which is the long-awaited part 4 in our series of videos documenting the scratch building of the very rare and elusive Gibson GA-1 RVT amp. Now, I know I said at the end of part 3 that I was going to clean up the workshop. Well, I did, and perfecting the circuit and making it sound its best ended up with a mess like this. It also required a bunch of changes both in components and in the circuitry. So I want to cover each of those in detail before we have our final audio demonstration, and in it you will hear the final result of not only this construction but also the changes that were made. I will make a list of each of those alterations, and we'll post a link to it in the video description so that any of you that are building or want to build this circuit can check out this list. Now, I'm not trying to tell you that you've got to incorporate my changes into the build. You may just want to proceed and build it as the schematic dictates. But I did want to make the list available to you so that you can see when you're finished if maybe some of the alterations I made don't improve the tone and performance of the amp. So without further ado, let's get started on the changes that I felt were necessary. I will describe them in detail. I will show you how they appear in the circuit, and I will also show you how they appear on the schematic. Okay, let's start off with change number 1, and it's by far, I think, the largest alteration and quite possibly the most shocking, no pun intended. As you recall, we started out with a 7199 in the V1 position, and we decided, nope, that's too hard to find and too expensive. So I went with a 6AN8 pentode triode, and I spent days trying to get decent tone out of the pentode of the 6AN8, and I could not do it. What I got was kind of tinny. No matter if you turned up the input even past 25%, you start getting blocking distortion, especially in the higher frequencies. I spent, like I said, days trying to make this work, and I could not. It never worked to my satisfaction. So I resorted to something that I am far more familiar with and works a whole lot better, and that is I went to a 12AX7 for V1. Okay, now it doesn't change the appearance of the tubes of the amp. We've already changed V1 anyway from 7199 to the 6AN8, so I changed it again. And I know some of you who are pentode purists will just turn off your computer right now just in disgust. But to the rest of you, let me assure you, to justify all the time and expense and 3 videos, the pentode would not cut it. Okay, so I installed this, and immediately there was a tremendous improvement in tone, volume, and just overall performance. Now, I've altered the schematic to reflect the inclusion of the 12AX7. As you can see, the lower triode, which drives the reverb tank, everything's the same except I went to a 1.5K cathode bias resistor. I use the same on the upper triode, a 1.5K, 25 microfarad at 50 volt bypass cap, and I changed the plate resistor from 470K down to the normal 100K that you see with 12AX7s. I ended up with a little bit higher plate voltage than the original schematic, and a little tiny bit lower down here, but let me tell you, as you'll see in the audio or hear in the audio demo, this really worked. The wiring of the 12AX7 does not really change things that much. You'd really have to know your stuff and have a schematic handy to be able to spot this modification. But resistance values are different, and the wiring of the V1 upper triode is a little different, but it doesn't look it. Change number 2, the input impedance. Before, on the low gain input, you had 94K of resistance to ground, which is the input impedance, and a whole lot of your signal is going to go to ground, hence low gain. Now on the high, they went with a 1 meg resistor. What I found is that's about 10 times the input impedance of the low gain input, and it was too much. Now the 12AX7 we know can cope with that, but the 6BM8 in my opinion couldn't. So instead of going 10 times the input impedance, I went with double. So I used a 188K input impedance resistor for the high gain input. Now you're welcome to experiment and try anything you want, but this is what worked for me. Change number 3. I found that the sound was lacking high frequency and clarity, so I put in a 150 picofarad treble bypass cap across the volume control. Okay, now you can see it right in here, 150 picofarad, and you can now adjust the tone control to where I think the sweet spot is right straight up on the tone control, and therefore I like this modification. Give it a try, see if you like it. If you don't, well, try something different. Okay, so that's change number 4. I thought that those shielded cables that I spent like 14 hours making in a previous video looked like hell, okay, and they really didn't end up long enough so that they draped over the magnet housing of the speaker. It just looked hideous, and it was also sort of a rattling or buzzing risk. So I went ahead and just used single wire shielded cable with rubber insulation instead of the intricately made double wire cable, and it works just fine. And for the other one, the single wire one, I just use a single wire shielded cable. I marked them red and black, and they work great. There's no hum, and it's the way to go. Okay, so I apologize for wasting your time with this elaborate construction, but I really thought I was doing the right thing. Okay, and I found out different. Change number 5, which we already discussed, but I wanted to show it to you on the schematic, and that is the addition of an additional filter cap of 10 microfarad and a internodal resistor of 10K in the plate supply to the preamp triode. And it just cleans things up, cuts down on any background noise, and it reduced the voltage a bit so that it was much closer to what would be appropriate for that particular triode. Change number 6. For the supply to the reverb tank, it was taken from this lower rail, which was in my case 288 volts, and that was just too much, I thought, to send over here to our reverb driver transformer. So I simply moved the connection for the supply from before the 22K resistor to after the 22K resistor, and ended up with about 228 volts, which was pretty much ideal for the reverb driver. Change number 7. The output from the oscillator tube that comes up here to go into the grid of the 6BM8 pentode output tube was just too strong. Okay, the intensity of the tremolo was too great. So what I did was I lowered this, allows some of the signal to go to ground. The schematic says 220K. I found by experimentation 150K sent more signal to ground and gave a much more pleasing tremolo intensity. Now, for those of you who have space on your chassis and an interest to do so, all you have to do is use a potentiometer in this position, say a 250K pot, okay, with a fixed resistor so that you don't end up grounding the output, and you'll have a tremolo intensity control. So that's where you would put it, right there. If you want to, I didn't. I simply adjusted so that I had what I thought was a very pleasing tremolo intensity. Change number 8 is I changed the primary wiring scheme, as we always do, where you have the fuse and the switch in the black wire line. The white wire goes directly to the other primary lead on your power transformer, and of course we eliminate the death cap, and we run the green grounding wire to a secure chassis ground, and we see it here. I believe I've already discussed this with you, but anyway, it is a change from the schematic, so I wanted to emphasize it. Change number 9, all of the operating voltages were a little too high with the power transformer that I chose. Now, you may pick an alternate or different transformer and not have that trouble, but in every case I was getting like 40-50 volts over what it should be. And the easiest remedy, and not one that I particularly love to do, but it works, is I put a resistor in the B plus line. I put a 470 ohm 5 watt resistor in the line. Now here it is. I put it right on the rectifier tube base, and so that the B plus runs through this before it goes to the circuit. Now I did my calculations, and there's only 1 watt of heat that's generated through this resistor of power, and the 5 watt then is far more than it would need. It still gets warm to the touch, but it brought everything down to really pretty close to ideal levels. Okay, so that's change number 9. Once again, you might not need it. And that brings us to change number 10, and it's part of the effort to properly bias the 6BM8 output pentode. As we saw in an earlier video, the bias was way too hot. So what I wanted to do was bring down the plate voltage and the plate current so that we get a decent plate dissipation. And to do that, I put a 220 ohm 1 watt resistor in the line that feeds the primary of the output transformer. And that brought the plate voltage down to 265, which is exactly what the schematic recommended. Next step was change number 11. Then, to reduce the plate current, I increased the resistance of the bias resistor from 680 ohms up to 820 ohms. And I ended up with this plate dissipation, which is slightly below 7. Okay, the plate current 23.8, and the plate voltage of 265 from the plate to the cathode. Okay, so also now if you're doing this, if you're adding in this supplemental resistor, be sure that you add it to the resistance of your primary winding of the output transformer for your calculations of plate current. Okay, so with that change of number 10 and number 11, I ended up with essentially an ideal bias for my 6BM8 pentode output tube. Now please bear in mind that when I give you the specific values for my circuit, they are correct for the 6BM8 tube that I used, for the power transformer that I used, and for the output transformer. So yours may be different, but I'm giving you ballpark figures here and trying to remind you so that you won't forget any of the details that are necessary in the recreation of this circuit. Also, I'm aware that the tube handbook readings that we looked up for the 6 BM8 pentode said that if the plate voltage was over 200 volts, that you should keep your plate dissipation down below 5 watts. Well, there's just no way in heck that I can bring the plate voltage and current down that low and still have what I think will be a reasonably powerful, good sounding amp. So I'm going to roll the dice, okay, and ignore that warning and abide by the 7 watt limit, which I think is far more realistic. Also recall that Gibson was biased at around 8.3, so this is definitely, I think, a step in the right direction. One last comment on the 14 changes that I made in the original circuit. That is, I could probably, if I had enough time and enough energy, could do 14 more. Okay, I think you could probably work on almost any amp circuit, and this one for sure, forever, for the next 10 years if you want, changing values here and there and trying to perfect it. But just like an artist with a painting, you've got to decide finally that it's as done as it's going to get, okay? So you've got to just set down the paintbrush and soldering iron and accept it as it is, and that's what I've done. Okay, some of you may come up with other tricky modifications here and there, and more power to you, but this is the best I could do in the time allotted. Okay, and I hope that the end result is pleasing. I thought I'd take a few seconds out from the video to show you little Mitzy. Her fur got so matted and tangled that we had her kind of shaved for the summer so that she can stay cool, and also to get rid of all those tangles. Now here she is taking a little snooze. She's tired out after that audio demo, but she's just a great little pussycat, furry or not, and also a excellent musician. Change number 12. I completely re-engineered the NFB circuit. Okay, remember it was switchable where it was either on or off. Well, I found a better way to do it. Okay, I reinstated the 47K resistor for the high NFB. I put in a 100K resistor right behind here. Remember this had that jumper across there? Now we have two separate resistors. So with our switch, we can select either high NFB, which should go through the 47K resistor, low NFB, which goes through a 100K resistor, or no NFB, which will be the central position. So now with our switch, we have a choice of no negative feedback, a very, very slight amount of negative feedback, and a little more negative feedback. Okay, so you have 3 choices instead of 2. Right, so that will be change number 12. And also I found out, much to my pleasure, that with the 12AX7 tube, with the 6 BM8 biased properly, it's like all of the other amps that I have tested and demoed. The NFB off sounds best at sort of low to moderate volume. Before, I had to have a lot of negative feedback when I had the 6AN8 in place. That high amount of negative feedback was necessary to cut down on the blocking, distortion, and just the overall hideous sound. Okay, now, with it set up as I have it here, no negative feedback, as you will see in the audio demo or here, really works great. Change number 13. Remember, I was going to use a Weber 4 ohm 12-inch 30 watt speaker. It's an Alnico speaker, and I'll be honest with you, I think because it's a new speaker, it's not broken in, plus it's an Alnico speaker, it tended to emphasize the high frequencies a little too much. And in an amp with like 3.5 watts output, you're looking for a little warmth. Okay, that ice pick kind of staccato treble is just not the kind of sound I was looking for. So, and I'm sure this would be an absolutely fabulous speaker and a different amplifier, but in this particular case, I thought it best to go with my tried and true, a 1968 Jensen C12Q speaker in absolutely mint condition. Okay, it's a special design speaker with the ribbed cone, and it's in absolutely superb shape. And I'm telling you, on the audio demo, I think you're going to like it. Okay, it has a nice bass portrayal. It's a little warmer. It's a well broken in speaker, and I think you're going to like the sound. And now we're ready for alteration number 14. The schematic shows a either switch or foot switch here to ground the reverb signal and keep it out of the circuit. Okay, I thought with a 2 meg pot here that by turning it down all the way, you would think all the way down to where all of the signal is going to ground, that would effectively turn off the reverb. Well, it didn't. The reverb is so powerful in this thing that, as you will hear in the audio demonstration, because I had not figured this out at the time of the audio demo, you're going to hear a little reverb in there where it shouldn't be. Okay, so I ended up having to pull the cables on the tank to shut off the reverb. So what I've done is I went back in and installed a RCA jack here, and I've run it over to the position in the circuit between the 0.02 coupling cap from the 7th terminal of the 6EU7 triode, between the 0.02 microfarad cap and the 1 meg resistor. I ran a wire, a shielded cable, it's right here, comes over to the RCA plug, and then I used a shielded cable that I plug into the RCA plug. I'll flip this over and show you in just a minute. And I made a foot switch. Okay, I took a piece of 2x4 and cut it down to where it looked kind of foot switchy, and I painted it gold to match the amp, installed a standard on-off foot switch, and put some kind of high friction like felt or Velcro like material on the bottom so it won't slide around. And now we have a nice foot switch for our reverb. Now, in retrospect, what probably would have been better would be to make a double foot switch and do your tremolo and your reverb on foot switches instead of having, as I did here, remember the switchable, the piggyback switch that I put on the tremolo. It probably would have been a better deal to just have a wider foot switch base and put in 2 of these. Okay, that would have been the slick way to do it. And so for those of you who are planning this build, keep that in mind. Make yourself a double foot switch, and I think it'd be pretty elegant, and it would work great. And you need it. You really need it on the tremolo, and as I found on that reverb, it would sneak in, and you start hearing reverb and think, well, what in the heck, you know, did I have it turned down? Yeah, you can't trust it. It's sneaky. So, got to have a switch or a foot switch for both of them. And here is the RCA socket and plug and shielded cable that runs to our reverb foot switch. I'm going to make a decal that labels it for what it is, and I'm also going to make a plate for the cabinet where it would say Fender or something of that sort. I'm going to make a special plate for it, and I'll surprise you with that in just a second. Now, all the changes that we've discussed here are marked on what I've called the Master Schematic, and I've also included a sort of a layout diagram of the tone control, okay, which I discussed in the video, but for those of you who like diagrams, there it is. You can do a screenshot and print it out if you wish. As promised, I'm going to take some high-resolution photographs of this modified schematic and post them on the internet and provide links in the video description to help you to find them and download them. Well, it's finally time to install the chassis in the cabinet, and I thought we'd take one last visual tour of how it turned out. I've got the tube shields in place. You notice that the little foot switch decal came out fine. I've got those antique bronze knobs on there. I thought that was a really nice contrast with the black dials, and it also went along with the gold and tweed motif. And of course, one final tour of that surprisingly intricate circuit. When you think about it, you know, this is a 6-tube amp. You could look at it that way. Each of the 3 tubes is double, and of course you have the rectifier. But it's almost like a Princeton reverb, I guess, but very densely populated with capacitors, resistors. I'd like to think it looks acceptable, sort of like a jewelry box when you look in here. And also, one thing I wanted to draw your attention to is people complain sometimes about point-to-point circuits, because, as I've said, my analogy is it looks like a plate of linguine with wires everywhere. If you notice, there's really no wires to speak of that are evident other than some ground wires and the 6.3 volt filament wires. We see the shielded circuit wires, all of which are as short as possible and laid against the chassis itself. So anyway, I'm going to button it up now. I hope you've enjoyed the 3 prior episodes where we showed how we got to this point. Now I think it's time to put everything together and see how it sounds. And one final step that I almost forgot, I have to relabel this tube as the 12AX7, and I have to label the NFB with low and medium. And there we have the new decals in place, so that the descriptions of the tubes and functions are now all correct. Well, the chassis is finally installed in the cabinet. We've got our Gibson 12-inch vintage speaker plugged into the 8-ohm speaker jack, reverb tank in the bottom with the color-coded reverb cables plugged in underneath to the bottom of the amp chassis. So I think we're just about ready to go. Let's install that back panel that covers up all the wiring, and then we'll turn it around and check out the front. And lest I forget to draw your attention to the snazzy statement of authenticity located inside the cabinet. This way, when our wonderful amplifier creations skyrocket to 6 and 7 figures, there'll be no doubt that this one is legit. Here we have the rear panel in place, and you can see it frames the chassis quite nicely. Also, I am proud to show that the little NFB switch is visible and can be adjusted with the back cover on. Also, I have those finishing washers on all 8 of the screws on the back doors. A viewer told me that that's all that was needed to make the cabinet perfect, so I went out and got them. Okay, and you're right. Thanks. And here at last is the full frontal shot with the little gold plaque that was made for the amp to personalize it. The control panel awaiting the strumming of Jack and Mitzy will be performing for us today. She's been taking lessons with Tom Bukovac, and he pronounced her one of his finest students. So as we prepare for the audio demonstration, why don't you run to the store and get your six-pack of beer and your crying towel and assume the position, because we're just about to start. I hope you're back from the store and ready for the audio demo. The SM57 sure is. And it's aimed right at the center of the speaker cone, and I think we're ready to start strumming some hopefully familiar tunes. Well, before we bring this video to a close, I just thought I'd make a few comments about the audio demonstration. I'm sure you have your own opinions. I just thought I'd share mine with you. First off, I apologize for that sneaky reverb getting in there, but the addition of the reverb foot switch has eliminated that. I think in retrospect that a tremolo intensity control would have been a good idea. I thought the tremolo intensity was fine, but I thought in the audio demo it came across a little strong. So if I were you, I would either reduce its intensity with a fixed resistor or add an intensity control pot. I thought that the high gain at kind of a 50% volume sounded by far better than the low gain input. And I thought that the NFB really was better switched off. It may have its uses in some cases, but in most I really think that just the straight non-NFB tone was the best. Also, I've been a little remiss lately in including any hot rod content in the videos. Now, we covered the kitties in like part 2, part 3, but I really haven't had any hot rod segments at all. So to make up for that, I'm going to have a photo montage with music at the end of this video, which will document the scratch building of a 1929 Model A pickup truck, turning it from a rusted out heap that I bought on eBay from Tennessee into what I think is a really snazzy, good running hot rod. Okay, so if that appeals to you, stay tuned at the end, and I think you'll get a kick out of it. Thank you. Well, I guess that's about it for this 4-part video extravaganza, chronicling the hand building of the elusive Gibson GA-1 RVT amp. Hopefully you were as pleased as I was with the audio demo, bearing in mind that this is a 3.5 watt single-ended amp, but I thought it really did well, especially for one with just a puny tube count of 3 miniature tubes. I also want to take a few moments here to thank my PayPal contributors and Patreon patrons for their support for another month and keeping us on the air and advertising free. If you'd like to join them, I'll put links in the video description which will enable you to do so. I hope you felt that Mitzy upheld her end of the audio demo chores. I really did, and to celebrate, I think we'll take a couple weeks off from amplifiers and workshop duties and just sort of take it easy. Okay, and I suggest you do the same. Okay, and also be sure you stay hydrated, okay, stay healthy, and stay tuned.